Good morning, everybody. Firstly, thanks for coming to our Brussels Public Sector Summit. It's exciting to have you all here. My name's Stephen Bryan. I'm on our technical and developer evangelism team at AWS. That sounds very fancy, but what that really means is that Amazon pay my salary, but I work for you. So my job is to really work with developers and technical professionals in the community and make sure that as a company, we're engaging with developers and technical professionals in a way that resonates well with them. So my details are there on the slide. Any feedback around this session, generally how we communicate through documentation, through our marketing practices, always open to hear feedback from you as customers. So in this first session, we'll be talking about building intelligent apps using API or maybe AI services, it might have been pitched as. And this session really is around how can you add intelligence to your applications without any machine learning experience required and basically provide better experiences for your customers. So if we look at our mission at AWS, when we think about the broader machine learning topic, our mission is to put machine learning in the hands of every developer. What that means is we want to use our years and years of experience of running machine learning and artificial intelligence at Amazon to make it as easy for you as possible to use machine learning technology and get the advanced capabilities that people expect today in your applications for your business. So when we look at that approach, and I won't touch on all of these, but we've done a lot of work over the last few years to enhance our machine learning capabilities, specifically around our pace of innovation. In the last year alone, we've had over 200 new major features and services for our machine learning portfolio. And over 90% of those features and services have come directly from customer feedback from people like yourselves. So we're committed to having a secure, scalable machine learning capability that continues to grow and adapt based on customer feedback. And when we look at that from a product perspective, and I apologize, this is a bit of an eyesore, lots of icons on the slide here. But when we look at that from a product perspective, we really look at it in three different areas. The first area is at the very bottom of the slide here, which is the infrastructure and frameworks. So infrastructure and frameworks is really designed for data scientists and data engineers, people who want to get close and hands-on with the infrastructure that powers some of this machine learning capability. So at this layer, we have a couple of things. Firstly, on an infrastructure perspective, we have our P3 and P3 networking optimized instances. These are our GPU instances. These are powered by NVIDIA GPUs and are very commonly used for deep learning type workloads. But we also, I think it's worth calling out that from a non-GPU perspective, so our Intel-based instances, our C5 instances, for example here, we've actually done a lot of work to optimize things like TensorFlow and MXNet to run on non-GPU instances, working closely with Intel to optimize those instances. So basically, what that means is you don't necessarily always have to be using a GPU or an expensive instance type to do your machine learning or deep learning work. So we've worked very close with Intel to optimize that and try and reduce the cost associated with doing machine learning at scale. And then we have a product called AWS Greengrass. Greengrass is a runtime for embedded devices or Internet of Things devices. It gives you the ability to run things like AWS Lambda functions at the edge in an Internet of Things device. And the reason we talk about that in the sense of machine learning is because we provide the ability to deploy machine learning models at the edge in a consistent manner using AWS Greengrass. And then making use of all this infrastructure, we provide what we call our deep learning AMI, or Amazon Machine Image, which is a virtual machine image which is optimized for frameworks like TensorFlow, PyTorch, MXNet, and other common machine learning frameworks. So it's optimized to get the maximum performance from those frameworks. So that's the kind of infrastructure and frameworks part of the story. But what we also see is that people want to do more machine learning. People want more control over their data. They want to use custom algorithms. but they don't necessarily want to have to worry about the heavy lifting with running infrastructure and scaling infrastructure. So in this middle layer, we have this product called Amazon SageMaker. And SageMaker is a platform for building, training, and deploying machine learning models at scale. So what it does at the build phase is offers you a managed Jupyter notebook. So if you're not familiar with data science or data engineering, Jupyter is an open source notebook technology that allows you to collaborate on code when it comes to data science and data engineering. We provide a managed Jupyter notebook at the build stage. And then when it comes to training your machine learning models, we have basically a simple API that you can call to say, I want to train my machine learning model on this many nodes of this size, and we take care of all the heavy lifting, spinning up the containers, launching the right framework for you to do so. And then finally, one of the hardest things in this space is actually deploying your machine learning models so you can do predictions against them. The deploy phase allows you to one-click deploy, and you get a simple API that you can use to do inference on your machine learning model. So SageMaker offers this kind of platform that removes a lot of the heavy lifting associated with running machine learning infrastructure. Before I focus on the top one, I just want to talk about a few things we've done to make it easy for people to get started at that layer. A few years ago, we launched a product called AWS Deep Lens. Has anyone seen the Deep Lens before? A couple of hands. So Deep Lens is a deep learning enabled video camera. You can buy this on this very popular retail website called Amazon.com. The Deep Lens basically allows you to very simply, through a few clicks, start to get using Amazon SageMaker. So we provide some example projects, some sample projects. Some of these are, is it a cat or a dog, face detection, these kind of things. And this is a device you can buy, and within a few clicks, you set up with your AWS account, and you're deploying a machine learning model straight away. We also make it possible to start deploying your own, move to that next stage, which is start deploying your own SageMaker models onto the Deep Lens device as well. So just really trying to remove the friction when it comes to people getting started with these technologies that sometimes seem very complex and advanced, but can actually be simplified with some simple projects to get you started. So we had a lot of fun with Deep Lens, and we thought, why not go one further? So we built a 18th scale race car called AWS Deep Racer. So this is a small race car, but it's completely powered by a type of machine learning called reinforcement learning. It's a very up-and-coming type of machine learning. And basically what you do is you train this car to drive around a track. There's a specific size track, and you train this car to drive around a track using machine learning. So out of the box, it won't do any driving, but you train it to drive around a track. So we work closely with Intel to work on the kind of edge compute inside the car. And what we provide is this virtual kind of simulator. So you can actually, you don't need one of these cars necessarily to do the machine learning work and train it. You can train it in this virtual simulator. But because we're in the Benelux, actually, next week we'll have our AWS Summit in Amsterdam, and we will have an actual physical Deep Racer track at the AWS Summit in Amsterdam. We're also running a workshop, a 2-hour workshop there for people to get started with Deep Racer, which I think is open for pre-registration, but may already be oversubscribed. So we're running a workshop for Deep Racer, but then we'll have the track there, and that will be part of what we call our Global Deep Racer League. So we thought we'd make it a bit fun. We want people to get excited about reinforcement learning with Amazon SageMaker. So this Deep Racer League is going to all the global summits around the world. And then if you win the league in your local region, you'll get a free ticket to Las Vegas, to our AWS reInvent conference, where you can participate in the grand final. And basically, it's who can build the most optimized machine learning algorithm to get the car around the track as quickly as possible. So we launched this in November in our reInvent conference last year. The time was around 17 seconds around the track. In Paris, just last week, I think they got to 10.4 seconds. So it's getting pretty competitive. So there's lots of work going on to optimize the models and get and win the race. Interesting thing about Paris, I think it was a Paris Summit. The guy that won the race at the Paris Summit wasn't a data scientist. He didn't have any machine learning experience. He went to the workshop to learn more about machine learning and ended up building the most optimized algorithm for Deep Racer that we've seen so far. So really, really easy to get started and a really nice way to ease you into learning more about machine learning. So I just wanted to touch on a couple of those if you're interested in that lower layer of the stack and getting started there. But the bulk of this talk is going to be around what we call our kind of AI services. And these are services at the very top of that original picture. And the real goal here is that you run machine learning with no machine learning experience required. To use these services, you simply just have to integrate these APIs into your applications to get intelligence from them. So we have a range of services here from chatbot services to transcription, text-to-speech, and then a couple of services on the end here called forecast and personalize, which are new services, one for forecasting and the other one for personalization, so recommendation engine type work as well. So with these ones, they're a little bit different because you have to preload them with a bit of your own data because recommendations is very specific to your customer base. But you still don't need to be a machine learning expert. You just load your data. We take care of optimizing for the right algorithm. So for the rest of this session, what we're going to do is dive a bit deeper into some of these products, talk you through some of their capabilities and how customers are using them. And then we've got a few fun demos through the way as well, just to make it a bit exciting so you're not just hearing me show you slides along the way. So one of the key things around these services is how easily you can integrate them together. Quite often we see people using these AI-level services in a kind of chained manner. So in this example here, we are taking some audio input, we're storing it in Amazon S3, and then we're using our serverless computing platform, AWS Lambda, to transcribe that audio into text. And then we're sending it to Comprehend, which is our natural language processing service to aggregate that data and visualize the sentiment and that data for the business. This is just one or two API calls to these services that are pre-trained machine learning models, and with this simple architecture, you'd be able to get sentiment analysis from audio calls, for example. So really easy to start chaining these together. So I just wanted to share that so that you can think about that as we talk through these services, how you may put them to work in your business. So one of the first areas we focus on is vision. And in the vision space, we have a product called Amazon Recognition. Recognition is a video and image analysis service, so it works for either media type. And it does things like object and scene detection, facial analysis, facial comparison, those kind of things. We'll just talk through some of the features. Firstly, I just want to show this example of recognition being used in a football match. So this is video recognition. It's doing activity detection, so it's, or object detection, sorry. It's tracking these objects, which are these people that are running around the football pitch. But it's also doing face detection as well here. You can see it's actually picking up the name of the football players as they play the game in real time. This also comes with this was something we built for a media conference in the United States. But it comes with a whole dashboard that at the same time is actually, we're gathering much more data from these faces. We're detecting the faces, we're seeing who it is, but then we're gathering sentiment from those faces as well. So you can see, for example, when this free kick's about to be taken, what the sentiment of the goalkeeper is at that specific time. Probably not very positive. Another use case for this was the royal wedding in the UK. We actually worked with Sky News to do celebrity detection, which is a feature of recognition. So when celebrities were turning up to the royal wedding, we were able to tell you who was arriving at what time, and you can see David and Victoria Beckham here on the screen. One of my favorite features, and we'll actually demo this a bit towards the end, is something called, it's the detect text API, but it's basically OCR, or optical character recognition. It's the ability to detect text from images. Again, very simple API to tell you what text is inside an image. It doesn't only work for kind of digitized text, it will work for handwriting, obviously with a varying degree of accuracy, but we'll tell you the probability of each character that we've detected in the response. And but it'll work for handwriting, it'll work for kind of font that's printed on memorials, for example, those kind of things. So it's not necessarily just for digital type text. Object and scene detection. So this is the ability to detect both the scene. So we can see, for example, in this image here that there's a road, for example. But we also pick up the objects, and then we put a bounding box around those objects as well. We provide you the details so you can locate those objects within the image. Interesting use case for this, Tinder, the dating app, use this. So if you're on a beach often, and someone else is on a beach often, then they may decide to match you with someone who has similar interests, being on a beach, for example. So it's an interesting use case for object and scene detection, but one that's out there in the wild and being used. Facial analysis will provide things like, are your eyes open? Do you have a beard? Are you probability of male versus female? Are you wearing sunglasses? We'll also provide the bounding box for the face, as well as the key attributes such as where the pupils are, where the nose is, those kind of things. And then we do face comparison, which I find highly interesting because I'm an identical twin. So facial comparison is the ability to tell if one face is the same person or the other, and this is obviously what we're using for our celebrity detection feature as well, but this is the ability to upload your own faces. And you can create something called a face group or a face collection, where you upload a group of faces, and then you can, based on an input, detect whether that face is present in that image or not. So AWS recognition, image and video analysis using computer vision technology to very simply give you APIs that do things like detect in text, faces, comparing faces. There's one other feature I haven't mentioned, which is content moderation. So we'll look for things like nudity in images through content moderation as well. So various very easy to use but powerful features that you can very simply add capabilities to your applications. Another product we have is Textract, and this is what we call OCR++. So this is the ability to detect text in, convert documents to text, digital text in long-form documents. So let's say an energy bill or a bank statement, for example. And the reason we say OCR++ is because it doesn't only look for text in documents, but it will also go a bit deeper and kind of digitize things like tables inside your document for you as well, and convert them into a digital format for you. The other interesting thing about both Textract and the Detect Text API from recognition is they're not language specific. As long as you're using Latin characters, you have the ability to detect the characters within the text. Doesn't care if it's what language the text is in, or if it's well written, or if it's grammatically correct. It's just detecting characters inside the image. So there's no issue if you're French, Belgian, Dutch, whatever it may be. It should detect the language for you. So one of the common things we see people using are chatbots. Now, chatbots are becoming extremely popular for various use cases. And we have a product called Amazon Lex, which is basically the technology inside the Amazon Alexa system that allows you to do natural language understanding and create chatbots for both text and voice inside your applications. So it plugs into things like Facebook, so if you're doing Facebook Messenger for customer service, for example, or Slack for any internal chatbots that you may want to build. But it also plugs into things like Twilio, so you can do SMS conversation with it. But then there's a simple API for you to integrate into your own applications as well. And it's really intuitive to use, and there's a few key constructs. In this example here, we're booking a hotel. So the first thing when you're building a bot is you need to understand the intent of the user. You need to understand what is the user trying to do when they build this, when they use this bot. And in this case, the intent is to book a hotel. In order to identify the intent, you need to train the bot on with what we call utterances. And utterances are the sentences or questions that your users may ask of the bot to trigger such an intent. And then obviously to go and fulfill whatever the request is that you're trying to fulfill and provide the end data back to the customer, you need to, there's specific variables or parameters that need to be filled. So in the sense of booking a hotel, these will be things like the check-in date, the check-out date, the number of guests, for example, or the city would be another important one, I guess, in terms of booking a hotel. So these are the variables that you need to, the kind of mandatory variables that you need to be able to fulfill the request. And we call them slots. And then obviously finally fulfillment. What are you going to do once you have all the data you need to go and fulfill that request? So Lex is pretty powerful. I'll just walk through this book a hotel example. what happens, this is a voice example, not a text example, but what happens is you get the audio input, and the first thing we do is automatic speech recognition, and then we do natural language understanding. So from someone saying, book a hotel in New York City, we can understand that they're probably, looking to book a hotel. We understand that kind of intent based on how we've trained Lex with our utterances. But we also know that specific strings map to potentially specific slot types. So we have a ton of pre-built slot types, things like cities, authors, landmarks, these kind of things, where we will use natural language understanding to automatically detect that we think that's a city that you're providing to us, so then we can pass it through to fulfillment and provide the best customer experience, so you don't have to keep prompting for data that's already been provided. And then we have the ability to confirm, so this, can I go ahead with the booking? We have the ability to confirm to the user that they want to go ahead once we've filled all of the slots before we actually go and do fulfillment. And fulfillment's typically done using AWS Lambda, which is our serverless computing platform. So when you're building a bot, one thing to think about is utterances. The real tip here is put as many of them as possible into your bot. The more utterances you have, the more chance that you're going to provide a better customer experience. So we have some customers that have thousands of utterances or different interpretations of things that customers may say just to trigger one intent. So we encourage you to come up with as many of these potential things that a customer would say to a bot as possible. You'd be surprised, but there's quite a lot of humans don't necessarily say the things you always think they're going to say. So through a lot of testing, you find that the more utterances you have, or the more variations of text, the more accurate the bot will be in being able to fulfill or detect the right intent immediately. And then obviously think about the slots that you need. These are as I said, the mandatory parameters that you need to go and do fulfillment. And we have these things called slot types. So you can see that the destination is of type city. So we're looking for a specific type of language here. And then the check-in and check-out are of type date. And these are pre-built slots inside the Lex system that exist, but you can also create custom slots. So you could create a custom slot to for example, I don't know, AWS products, for example, or AWS services. And you could provide a list of AWS services that you would expect the user to provide at that point. And then Lex will automatically prompt the user backwards and forwards to fill those slots that are mandatory slots. Just going to show you a demo in a second of that, but before we do, I just want to touch on Amazon Connect. So Amazon Connect is a cloud-based contact center service, so IVR, call management, call routing, call recording. It's pretty much the technology that Amazon.com use to do customer service externalized into a product for our customers at AWS. And the reason I mention it now is because it integrates heavily with Lex to offload customer calls to robotic agents and then offload back to agents, human agents when maybe the customer's confused or the bot can't quite work out what the next step is. So Amazon Connect is the contact center in the cloud that integrates with Lex quite heavily. So for use cases, customer service or call center, Connect is the service you want to look at. So I just want to show you a quick example, and while I'm just getting this up, I'll give you a bit of background. So I live in a place where my neighbors have a Facebook group. So I don't know if anyone else has a Facebook group for their neighbors, but we have this Facebook group for our neighbors. And I was getting very frustrated because what happens is they always ask every week, does anyone know which bins are being collected this week? Is it the recycling waste? Is it the general waste? Is it the garden waste? And this was becoming quite frustrating to me that people kept asking the same question. So obviously being an engineer, I thought, I can automate that. So I built a bin bot. So I built a Facebook Messenger bot for my neighbors so that they can ask when the bins will be collected. So I'm just going to show you that what that looks like now. So I have this bot called Bin Times. And the first thing you notice here is that I have two intents. The one that's automatically loaded is the bin help intent. The bin help intent, you can see I actually can't edit anything here. This is what they call a built-in intent. And there's a couple of these available. They're pretty much inherited from Alexa. You can see things like, resume, stop, start, those kind of things. But one of them is the help intent. And this is very useful. For example, if you want to submit a bot to Facebook, just a pro tip here, if you don't respond to things like help, how do you work, these kind of utterances, then Facebook will reject your bot. So the first thing they do is ask how do you work or help to your bot. So by having this built-in intent for help, I can just add this to my bot and then handle it during my fulfillment so that customers can ask for help, and I don't need to worry about training Lex to know what it looks like when someone asks for help. So that's a pre-built intent that I added to keep Facebook happy, but it's a good practice for customer experience as well. But then I have this bot for my neighbors called this intent called getBinDate, and I only have a few utterances here. First thing to show here is that you can actually use a slot type in the utterance. So when will the waste type be collected, or when will the recycling be collected, for example. Or you can have utterances that are just strings of text, and then we'll prompt for the slot types that are marked as mandatory down here, and you can configure the prompt here. What bin would you like the info for? And then in terms of fulfillment, we just use an AWS Lambda function. So a bit of, I think this is written in JavaScript, a small bit of code, and in my case, I'm just going to my local authority's website to grab that data and provide it back to the users. So you can see here from the console, it's really easy to get started without really writing much code to start building the customer flow and getting the data you need from your customers. So we're just going to ask my bot and pray to the demo gods that it works. So I put in a custom slot type here where I can type things like recycling. And the recycling bin will next be collected on Friday the 12th of April. So just a simple example of how you can build intelligent bots using Lex. And most of the work here is in the console in terms of prompting and confirmations and making sure all the right slots are delivered for your fulfilled before you go to fulfillment. Then at fulfillment, you're really going and integrating with third-party APIs to actually go and do something to provide the response back to the data. And we have SDKs available for the fulfillment end, so that you can structure everything correctly. But basically, you're just providing JSON data back in the right format for Lex to understand. So I have another demo, slightly built around Lex, but it's more a recognition demo. So as I said earlier, I have an identical twin brother. This is Dean. Everyone say hello to Dean. He's my identical twin brother. Picture of us both together here. In a panic room, actually, an escape room in the UK. So I'm on your right, and Dean is on the left. And what we're going to do is we're going to play Beat the Bot. So what I've done is I've trained Amazon Recognition to know who Dean is, and I've trained Amazon Recognition to know who I am. And we're going to try and see if the audience or Recognition can do a better job of guessing who is who, just to demonstrate the accuracy of recognition. So let's dive into that. Sorry, just before I get to the demo screen, just all take a second to look at this fabulous picture and get a sense of what Dean looks like and what the differences are between Dean and Steve. Now, we are genetically identical, so understand that's not the easiest ask of an audience at 9 o'clock in the morning. But take a look, rough differences, see if you can tell the difference. And now what we're going to do is we're going to go over to here, and I have another bot. For some reason, I've wrapped this around a bot just to make it super easy. I have a bot that takes a URL of an image, and it will tell you who it is and what the accuracy is. And what I've done here is I've gone to, just to show you how simple this is to do, I've created a collection. This is a face collection. I've called it Twins. Simple, one API, I've created a collection of faces. And then what I do is I index faces, and I say there's maximum of one face per image, and I'll just provide the file to Amazon Recognition. And I've given this one an external ID of Steve, and this one an external ID of Dean. And I've simply taken 5 photos of me, 5 photos of Dean, and I've told Recognition to label them accordingly. So you can see there, a couple of API calls. We've now got our own collection of faces that we can go and do searches against. So just again, Dean, Steve, see if you can tell the difference. And now what we're going to do is play beat the bot. Right, so firstly, this photo, audience. Is this Dean or is this me? Dean, hands up for Dean. Well, it's nearly unanimous. It's nearly unanimous. Hands up for Steve, any? Couple, 2 or 3. Right, so we're going to take this URL, this image, we're going to throw it into our bot, and we're going to say, let me just zoom in on this for you. Which twin is this? Ah, it's me. It's me. You were all wrong. Not all of you. Some of you are right. But you were mostly wrong. Interestingly, as humans, we look at things like hair. I don't often look at much hair, especially when I'm looking in the mirror. But we look at things like hair. And obviously, when we're looking at a deep learning computer vision algorithm, it doesn't necessarily care about if I have hair or not. It's actually looking at a vector of the face and understanding the contours and other things. Really interesting that it's able to recognize the difference between identical twins. Now, if you were to ask if it was the same face and provide 2 images, there would be a high degree of similarity as well. There would be a, probably higher than 90% similarity. But because we've trained recognition with both faces, it's able to find the one that's closest to me or Dean, and is able to actually pretty accurately tell the difference between both of us. So just to prove one more. So this one, anyone guess who this is? Dean, me? Dean? Or you think Dean? Okay. Let's give this one a try just to... It's Dean. 99.66%, that was Dean. So I think that's pretty obvious. I wasn't going to do 2 pictures of myself, although maybe next time I'll do that just to trick the audience a little bit more. But just a good example of how easy it is to build something using recognition. You can see here that this is a code for anyone who's interested, but basically this is written in Python. We're just getting the recognition client, and we're simply just calling one API, search faces by image, and then we're passing the byte array of the image. So one simple line of code, and we're doing a detection of faces after we've trained this system. So pretty powerful stuff. Right, that's fun demo 1 finished with. There's one more later. Cool. So another area where we have a lot of interest is around kind of language, and the first area of that is speech. And we have this product called Amazon Polly, named after a very famous parrot, that basically does text-to-speech. And the way we describe it is text-to-speech or text-to-lifelike speech. It's available in 58 voices, 28 languages. Really great for things like, we see it often used with game development, for example, virtual reality hosts, these kind of things, using text-to-speech to get lifelike speech. We see companies like Duolingo, the language learning service, using it to provide lifelike speech in many different dialects to their customers as well. And basically, when we say lifelike speech, and I don't have any audio, unfortunately, but when we say something like the weather today in Seattle, WA is 65F, we're using natural language understanding to actually say the weather today in Seattle, Washington is 65 degrees Fahrenheit, is what you'd hear from the service. So we're not taking everything just as it comes. We're actually using natural language understanding to provide it in the most lifelike way possible. And these are really, again, simple APIs. This is the AWS CLI, just an example. You can say synthesize speech, you provide some text, provide the voice that you want, the format that you want, and away it goes. We also support these custom lexicons, which is like a voice dictionary as well, if you want to train with any custom dialects as well. And as I mentioned, Duolingo are an example that use this for lifelike speech. Another service we have is Transcribe, and that's kind of the opposite of Polly, which is speech to text. This is a pretty straightforward service. You provide an audio or a video file for that matter, and we'll take the audio out and transcribe it to text for you. We support things like multiple voices, so if you're doing an interview, we'll detect which voice is speaking at which time and provide that in the output for you. And this is available actually real time or through batch as well, so you can do it as a batch operation. These are languages it currently supports, and more coming soon. Interesting example here, and this maybe maps to the architecture that we showed at the beginning, is RingDNA. They use it for their sales calls, so their inside sales team actually use Transcribe to transcribe sales calls, and they pass them through things like sentiment analysis to understand customer sentiment when certain key phrases are mentioned on the calls, so they're able to detect and improve their return from their sales calls through digitizing that or converting that audio to text and then doing natural language understanding on it. And language is a really big challenge for a lot of customers, and what a lot of people are looking to do is to get insights from unstructured text. So Amazon Comprehend allows you to do that. And what it does is it allows you to get the following 6 things from any text, any string of text that you provide. Again, there's a nice console where you can take a look at this in the AWS console, but you can provide batch documents to the API as well. And this is probably the best way to show you what the output looks like. You know, say, it will look for things like what we call named entities. So these are things like dates, locations, organizations, people. It'll also look at the key phrases in the text, what the sentiment is and what the language is. And then we also added a syntax API, which will tell you where common things like where the pronouns are in the text, where the adverbs are, where the nouns are in the text, and it will detect the grammatical kind of syntax of the text. And again, very simple APIs. If we take this example of I love cloud, we see that a pronoun is detected at offset 1, and we're 99% accurate that that's a pronoun. Similar for sentiment as well. Again, one simple API, detect sentiment, language is English, I love cloud. And what I like about this response is that we provide all of the values for you, so you can see whether it's, what percentage was mixed, what percentage was neutral, positive, negative. But then we quite nicely give you the overall sentiment at the top as well. So from a developer perspective, it's nice and easy just to grab that positive sentiment from the top instead of having to dive into the percentages and work out the greater value. So very popular for things like content personalization, semantic search, social analysis is very popular, especially for the sentiment feature. And then we have another feature of Comprehend called topic modeling, which supports you uploading basically large batches of documents, and then we'll model them into different topics. So we'll separate those and detect the topics that are mentioned within them. So this example here is of news articles, and you can see that it's detected which articles focus on storms, which ones around politics, the stock market, for example. So it has this batch API for topic modeling. You can very quickly, point it to a S3 bucket, for example, and it will go away and just run through your data in a batch process for you and give you the output again into an S3 bucket. It will give you the output that describes the different topics that your documents map to. And then just in November, we launched this feature called Comprehend Medical. So if anyone's working in, healthcare or even insurance, insurance is pretty popular, healthcare insurance. We have trained Comprehend to understand common medical vocabulary. So in this example here, you can see that sleeping trouble is detected as a symptom, so is a rash. It knows that at breakfast daily is a frequency, so it's able to take medical type language and terminology and detect what the key entities are and what the types are from that text as well. So a focus on a more kind of industry-specific view at natural language understanding that we launched just in November at AWS reInvent. And then finally, AWS Translate. Now this is pretty straightforward, natural language translation. We support, forget the number of languages, but 417 combinations. So that's pretty much all of these languages that you see on the screen. You can convert one to the other, except for a couple of traditional and simplified Chinese to other languages that we're still working on. But 95% of these languages on the screen you can, translate to each other. And a example of a customer that uses this is hotels.com. They use it to translate their websites in 41 different languages around the world. So what I want to do for the last 10 minutes or so is just show you a quick demo of how easy it is to add some of these capabilities to your application. So we're actually going to go in and add a bit of code. So if there's people in the room aren't developers, it is really, really straightforward to use these services. So Hopefully we don't lose anyone. The idea here is that I have this this app. It's written in Vue.js, JavaScript framework. It's a pretty terribly written app because I'm not a front-end developer, so it's pretty inefficient. But basically what it does is it goes to this API, and what I thought would be a bit of fun was to go and build this app called Inspirational Sentiment. So what it does, if we just refresh this for a second, is it goes to Instagram, and it gets the top 5 posts with hashtag inspirational quote. And I thought, what a good idea, let's go and see if inspirational quotes are actually positive or not. So that's what we're going to do. We're going to show you how easy it is to add this capability to your app. So it's a very simple application. We've got these 5 inspirational quotes. We do have to be a bit careful. Sometimes these images are, we should probably put this through content moderation before we put them on stage, but we'll see how we go. So what we're going to do is we're going to use 2 APIs from AWS. First things first, simply we're using serverless technology here. So I've got Amazon API Gateway at the front, giving me this HTTP API, and that's powered by a Lambda function. So this is a serverless function, which means that I only have to worry about the business logic, and I only pay when the code executes. And I'm paying in 100 millisecond increments. So really small increments of cost here. So here's my current code. It goes and scrapes Instagram's website for some posts. Again, pretty inefficient code, but that's not the point of the post. So first thing we're going to do is we're going to go and we're going to configure our, we're going to use 2 services. First things we're going to use recognition. Recognition is going to be used to do detect in text in these images. We spoke about this earlier, the ability to do OCR inside these images. So we're going to detect the text from the sentiment, from the inspirational posts, and then we'll pass it on to comprehend to do sentiment analysis on those posts as well. And we'll just pass that data back to the client. So what we're doing here is this is Python. We're using the Python SDK for AWS. It's called Boto. And we're just configuring both the recognition and the comprehend client to use our island region. And then pretty simply for, where do we want to stop here? Yeah, so I'll just copy this, sorry. No, that's not all of it, sorry. Up to there. So, So what we're going to do now is, first of all, I just realized that needs to be over there. Python really doesn't like the white space being wrong. So what we're doing here, and just to break it down, is for every post that we've got in our list of posts, we're downloading the image and converting it into a byte array. So when you use a recognition to detect text or any of its APIs for image, you can provide a link to an S3, an image in an S3 bucket, or you can provide the actual images as a byte array. So what I'm doing is actually just downloading it as a byte array and passing it directly to the recognition API. And again, very simple, one API call, recognition.detectText, and we're just passing the image with, that's gone terribly wrong. We're just passing the image as a byte array. And then the next bit of code here is, we won't go through it all, but basically what the detectText API gives you back is it gives you both words and characters. So I'm taking all of the words and I'm concatenating them into a string so that I can provide it back to the client. So if we zoom out somehow, here we go. So we just save this. Finally here we're updating our post attribute with a quote. So we go back and simply just refresh our app. We should see that when my terribly slow code stops running, see, I told you these are hit and miss. Let's start with this one. You should see that we have the quote here. We've done very easily, simple API. We've passed the image to recognition, and now we've been able to detect the text in the image with a high degree of accuracy. So from a simple line of code and a bit of string manipulation, we're able to get the quote from the text. What we do now is we will, finally, we'll just then call this comprehend client, and you can see here all we're doing is we're saying, and this is the same example that we saw on the slide earlier, we're using comprehend.detectSentiment, we're passing the quote that we just detected, and we're saying the language is English. Now, obviously, I could use comprehend to detect the language first and then pass it through, but for the sake of this example, we're just giving you a simple demo of how easy it is to chain some of these APIs together. So we'll just go into our Lambda console and just add that, no, not that one, he says. In here. We'll go into our Lambda console, we'll just add that in there. So what we're doing is we're, like I said, comprehend.detect sentiment, and then we're updating the sentiment with the sentiment of the response, which if you remember on the slide, I said at the top it had positive. That's that attribute that it's just grabbing there. So moment of truth, we get to see if you know, these inspirational quotes are actually positive or not. You know, typically when I do this, I get a bunch of stuff that doesn't have any text in it or has no relevance. I actually did this demo last week, and I'm not even lying. A picture from Instagram came up that said, "I love cloud." I could not believe my eyes. I was on stage, and I'm like, did someone in the crowd just post to Instagram and hashtag inspirational quotes? Was I mate? See, this one's pretty useless. This one's pretty useless. But this one's pretty positive, so maybe they are. And this one's pretty negative. Actually, I mean, it looks pretty negative, doesn't it? You know, so. And this one's neutral. So what I want to do is we're going to build on this demo. We'll open source it and share it for you to have a look. But we want to build like a little, a little pie chart or something for you to see what's going on. But really, the goal of the demo was just to give you a brief overview of the how easy it is to add these simple APIs to your applications. You know, if you're a developer, hopefully that was pretty, showed you how straightforward it is to just very easily integrate them. If you're not a developer, hopefully it showed you how easy it is so your developers can easily do it. Really is no machine learning experience required. I don't have to know anything about data science. I don't have to know anything about machine learning, and I can go and detect text in my images. I can do sentiment analysis. I can convert text to speech. I can look for objects in images. I can do real-time face tracking. I can tell you if a picture is me or my twin brother, even when, certain face recognition technologies out there on the market can't. I can tell you with accuracy that was me or Dean in that demo. So hopefully, a nice overview of the AWS kind of high-level AI services. Hopefully it was useful, and thank you very much.